All right, welcome to The Explainer. Today, we are diving deep into something that's, well, it's pretty much everywhere these days, one of the most powerful technologies shaping our world, machine learning. So, you ever stop and wonder how your streaming service just knows what you want to watch next? Like, it seems to read your mind, right? Or your music app puts together a playlist that's just perfect. It feels kind of like magic, doesn't it? Well, spoiler alert, it's not magic, it's technology. And right at the heart of all of it is this incredible idea called machine learning. This is the engine that's really powering so much of our modern digital world. So, what is it really? I mean, what does that actually mean? Think about it like this. For the longest time, programmers had to write out every single rule by hand. If this happens, then do that. Machine learning completely flips that on its head. It's all about letting the computer figure out the rules for itself just by looking at a ton of data. And this is where it gets really cool, because machine learning kind of mirrors how we learn. I mean, look at this. For us humans, our fuel is experience, right? For machines, it's data, just massive, massive amounts of data. We learn by comparing new things to what we've seen in the past. They do the same thing, just with data. It's a really powerful way to get your head around it. And just like people have different ways of learning, it turns out machines do too. We can basically group them into three main styles. You've got supervised, unsupervised, and reinforcement learning. So let's break down what each of these really means. Okay, first up, supervised learning. The best way to think about this one is like you're studying with flashcards and you've already got the answers on the back. You're learning with a guide, a teacher who's telling you what's right and what's wrong. So with this style, we give the machine a giant pile of data where everything is already labeled. For instance, we show it thousands of pictures labeled cat and thousands labeled dog. The algorithm's entire job is to learn the patterns so that when you show it a new picture it's never seen before, it can correctly say, yep, that's a cat, or nope, that's a dog. And to do this, machines have a whole toolkit of different algorithms. A really common one's called a decision tree. So picture the computer asking a bunch of yes or no questions to figure out if an email is spam. Does it have the word free in it? Yes. Is the sender address kind of weird? Yes. Okay, then it's probably spam. See? By learning which questions to ask and in what order, it builds a model to classify anything new that comes its way. Okay, but what happens when you don't have those flashcards with all the right answers? Well, that's where unsupervised learning comes in. I want you to imagine you're dropped into a brand new city. No map, no guide. You'd have to start figuring out the lay of the land on your own, right? This area feels like the financial district. Over there seems like the artsy part of town. That is exactly what the machine is doing here. So with this method, the machine gets a whole bunch of data with, well, no labels at all, no right answers provided. Its job is to just dive in, explore all that data, and find interesting patterns or groups all by itself. It might start grouping similar things together without anyone ever telling it what those groups are supposed to be. The main tool for this is something called clustering. There's a famous algorithm called K-means that basically looks at all the data points and pulls similar things into little groups or clusters. Let's go back to that streaming service. It might use clustering to find a group of people who, I don't know, love both old black and white movies and modern sci-fi. A human analyst might never even think to look for that weird connection, but the algorithm finds it and boom, a whole new audience to recommend movies to. All right, our third and final style is, well, it's completely different from the other two. It's called reinforcement learning. And the absolute best way to think about this one is learning how to master a video game. You don't read a manual, right? You learn by playing. You learn by doing. So in this model, you have an algorithm. It's often called an agent, and it learns by trying things out in an environment to reach some kind of goal. It's not handed a list of correct answers. Instead, it learns from the consequences of its own actions through pure trial and error. And the secret sauce, the thing that makes it all work, is a reward system. Let's go back to that video game. Every time the algorithm, our agent, makes a good move, like it finds a treasure chest, it gets points, a reward. But every time it falls into a trap, it loses points. At first, it's just guessing, completely randomly. But after trying millions and millions of times, it starts to figure out the exact sequence of moves that gets the highest possible score. It literally teaches itself how to win the game. Okay, so that's all the theory. But where do you actually see all this stuff in the real world? The answer is pretty much everywhere. Let's connect these big ideas to your actual everyday life. Let's start with your email inbox. That spam filter that saves you from a mountain of junk mail every single day, that's a textbook example of supervised learning. It was trained on millions of emails, shown what's spam and what isn't, and now it makes that call for you in a fraction of a second. And what about that streaming service we talked about in the very beginning? The one that feels like it's reading your mind. You guessed it. That's unsupervised learning at work. It's not that the service knows you personally, it just finds patterns, and it clusters you with thousands of other people who happen to have similar tastes. So that recommendation, it's not really for you, it's for your cluster. Now, reinforcement learning, this is where things get really heavy-duty. It shines in these incredibly complex systems. We're talking about things like optimizing the flight paths for an entire airline to save fuel, or managing a city's power grid on a second-by-second basis, or even building financial models that learn how to trade stocks by constantly testing strategies in a simulated market over and over again. Okay, so there's another buzzword you've probably heard thrown around, deep learning. Where does that fit into all of this? Well, the simplest way to think about it is that deep learning isn't some separate thing. It's a specialized, kind of superpowered version of machine learning. It uses those neural networks we mentioned earlier, but with way, way more layers. Hundreds, even thousands. And that's what allows it to tackle the most complex problems out there, like understanding human speech or recognizing what's in a photo. So, when you take a step back and look at the big picture, it all comes down to this quote, which really nails the key takeaway here. Machine learning is the foundation for so much of our modern, data-driven world, and it all boils down to one incredibly powerful shift. We've moved from building systems that just follow instructions to building systems that actually learn. I mean, from something as simple as recommending your next favorite song, all the way up to helping us tackle massive scientific challenges, machine learning is already reshaping our world in ways we're just beginning to understand. And that kind of leaves us with one last really fascinating thought. Now that we've built machines that can learn, what's the next thing we should teach them?